Hi, in this tutorial, we'll demonstrate how to train an object detection model practically and the different ways to deploy it to a LabVIEW application, taking the PCB inspection as an example. The ANSTS Model Training Tool, a crucial component in our process, is the first ever product that supports YOLOv10 for LabVIEW. It is designed to facilitate the training of object detection models, making it an essential tool for our tutorial. To get started, select the YOLOv10 option before you open a project. Once you're on the project, you need to load the PCB image dataset. ANSTS enables you to verify if the dataset is sufficient for training. Here you can notice that the data is invalid because there's a label category that hasn't been used on any image. You can modify the label information using the built-in ANS Labeling Tool. The Labeling Tool allows you to annotate and add descriptive labels to your dataset. Additionally, it will enable you to import label files from various formats such as YOLO, Pascal VOC, and JSON, thereby allowing the reuse of your original label information. Importing label files with ANSTS is a straightforward process. Just select Yes and choose your original label format from the drop-down list. Press Check Label and Map File Information, and then the software will verify and display the original information in the same dialog. Press OK to start the label conversion process. After that, all your label information will be automatically populated in your dataset. You can review and make any adjustments if necessary. Let's delete the object category that we don't need. After that, your dataset will be validated and ready to be sent for model training. Click Send Data to Engine to continue. To begin the model training, you need to set up some training parameters. Choosing the suitable parameter will depend on your application's requirements and dataset. You can quickly learn how to configure them using our library of help articles. Once the parameter is set, click Start Training to begin the model training, and you can monitor the progress in the training log. During the training process, a portion of the data will be selected for the validation set, which will be used to test the model simultaneously. You can either allow the training to continue or stop it manually based on its performance during the training and validation progress. After completion, you can review the model training log in the Previous Experiments tab. Click Evaluate to review and select Models to export. By clicking on your desired model, you can optimize and export it for GPU and CPU inferencing. Once the model is exported, the software provides a built-in model testing interface. You can choose whether to test it. In the testing interface, you can choose from various image sources, such as image files or integrated camera streams, for AI inferencing. You can also switch between the exported GPU and CPU models to compare their performance. The right panel will display inference information and provide options for result visualization. All exported models are zip files, and we provide two options to deploy the model into LabVIEW. First, deploy the model natively with the ANS Deep Learning Toolkit, ANSDL. Let's create a LabVIEW project to store the application. ANSDL provides many examples in VI that you can refer to or duplicate for your project. Let's manually create our object detection project similar to the example on the screen. After that, load the zipped model and an image sample to start the application. It works, but will stop immediately after the detection. To simulate constant AI inferencing, we need to add a while loop. This loop ensures that the AI model continues to process new data, making our application more dynamic and responsive. That's how you can create a LabVIEW object detection natively. The second method is to outsource the AI inferencing to AI Box. AI Box is an artificial intelligence hardware built in with ANS AI inferencing technology. AI Box's primary function is to enable smart video analytics from camera streams or other image sources. After performing inferencing, the AI Box provides a TCP/IP protocol, allowing you to send results back to LabVIEW through the application trigger for further processing. This reduces the application workload and enables seamless scaling of your project. To get started, we use the ANSTS client to connect and interact with the AI Box functions. ANSTS allows you to scan for AI Box IP addresses in your network. After detecting the IP, connect it and log in to the AI Box server. First, let's add the PCB image source and the trained model to the server. Next is to create the AI inferencing task and connect the task with the selected image source and model. Another advantage of AI Box is that you can configure advanced rules to define what objects you want to detect and how you want to detect them. Finally, create an application trigger so that when the object is detected, it will be sent to LabVIEW through TCP/IP protocol. Now let's run the AI task. ANSTS has a built-in live view so you can watch the inferencing in real time, and the event log page stores all events history. After receiving events from the AI Box, LabVIEW developers can proceed to configure their applications. And that's a complete solution for model training and LabVIEW deployment to scale up your project. Thank you for watching.